So we can also use the line function to do linear regression. Okay. So this is the format of the output of the line function. But let's use this data to illustrate how it works. So we can just say equals line. Okay, yeah, line. What was he asking for? He's asking for
You know the Y. The Y.
the y, the known
Yeah,
y,
which is sales.
the known y, which is sales.
Sales.
Thank you, thank you. Comma, the known x's,
Then X
which is
expenses.
advert expenses. Then this one,
Is optional. So
so we can even forget about it, okay?
yeah.
We can forget about this. Now, if you do that, it simply gives you that, okay? But that may not be sufficient. Let's just do line the no y's,
Sales.
no x value.
Calculated normally.
Let's use this one normally, and then let's say yes, yeah, true.
Yes.
Return
Oh,
additional
not
statistics.
regression statistics.
It didn't take. Okay. Let's take true. Okay, sorry. I know why it's not working. Before you do it, for it to give you the kind of output you want, you have to select, the space where the output will be. So we need 1, 2, 3, 4, 5 rows, 2 columns, okay? So you have to do that first of all. You select 5 rows, 1, 2, 3, 4, 5, 2 columns. That's where our output will be, okay? Then you can click in the formula bar and say equals linest, known y's, comma, known x, comma, okay? And if you just stop there, see, it will repeat all this. So in this case, it's actually giving us 2. There are 2 things I want to show you here. Let's do it like this first to avoid confusion. If I say equals linest, I just do y, comma, x, okay? So what is it going to give me here? It's going to give me just the slope and the intercept. Okay, let's compare this. It's giving me the slope and intercept. What do I mean by slope and intercept? Look at it. It's giving me this one, this value, coefficient of x, and this one. Can you see it's the same thing?
Okay.
It's not the same.
Yes.
This is the equation. Let me bring it close. The equation we got earlier from the scatter plots. So it's telling you what the coefficient of x will be. That's this 2.145 something. And what this will be. Okay, so you can now use this to form your equation. So you see that it's the same thing we are getting. This the same thing. We are saying y is equals 2.145. If you want to approximate it, you can just say 1 x plus what? Plus
84
8 4
2201.
0 1.
Hmm?
Yeah. You see, can you see it's the
Good
same thing as what we got from the scatter plot?
night.
Is it not the same?
It's the same thing.
So we could use the Linus function. That's the second method. Use the Linus function. Okay. Now,
I love to see you press that phone.
but if you want to
You
see
press
more,
that phone.
if you
Let me
want
thank
to,
you. Set your alarm and drop it.
if you want to see more details than just these two, if you want to see more details, you want to see all these things. Okay, we'll talk about some of these when we start doing when we start treating hypothesis testing. Okay. But let's say you want to see more details. Let me show you how you do that. In that case, you are going to select 5 by 2. 1, 2, 3, 4, 5 by 2. Click in the formula bar equals Linest. As usual, you select the Y, comma, select the X, comma. We can take true here. We want B to be calculated normally. What is B? B is this intercept, this 842 whatever. Okay. Want it to be calculated normally, then, comma, return additional regression statistics. You hold down Shift Control Enter. So this time around, it's giving you more details. What are these details? These are these figures, these things you are seeing here. Let me put it side by side. Okay, this is the slope. You can see slope. This is the intercept. What's intercept? Intercept is where the line cuts, yeah, this vertical axis, where it cuts through this y-axis. If you draw this line, if you extend it, where it will meet this vertical line. Okay, that's the intercept. That's usually what is here, plus that. That's usually what is there. So that is the intercept. That's the intercept. Okay, that's the slope. This is the slope of standard error. This is intercept of standard error. That's what we call standard error. Why do we have to have error or standard error? Because, like we said before, forecasting is not like soothsaying. Okay, it's not like where you have to do exact prediction. Usually there's an error, there's a variance. That variance is what constitutes the error. Then the arrow squared, what is arrow squared? Remember the arrow square we got before? What was our arrow square was, when we used the scatter plot, it was
70. Yeah, right, 70. 0.7311 by 73%.
Yes, 3%. You can see that's the same thing we are getting here. You see, it's the same thing. So that's the position of the arrow square. This one is standard error of y, based on the deviation of y from actual. This is the F statistics. Okay, when we are doing hypothesis testing, then we'll talk about F statistics. It's a test of variance. This is the degree of freedom. Okay. This is
start.
This is sum of squares for regression, sum of squares for residuals. Okay, so that is how that works. So, like I said, when we are doing the hypothesis testing, we'll talk more about some of these things. By the time we do hypothesis testing. Okay, so that's how you use your. This is how you use your whatever your. This is how you do hypothesis testing using the line. Sorry, this is how you do regression analysis
Regression analysis.
using the linearness function for linear regression. It's just for linear regression. It's for linear regression. If it's not linear regression that you want to do, then you cannot use linearness function. Okay. So that brings us to, there's also another function you can use for exponential regression. But let's just talk briefly about the other types of regression. Let's go back to our SY scatter. Now, which method do you prefer?
I wanted to say it. I prefer the scatter plot method.
Scatter plot method.
At least for a beginner.
Yeah, it makes life easier, right?
Yes, it makes life easier.
Yeah.
Except for maybe you want to do deeper analysis.
Analysis, yes.
Mm-hmm.
Most of the time, the scatter plot method is sufficient. Most of the time. If you use the data analysis, of which mine is not showing now, maybe by the time I restart my system, but I don't want to waste your time with that. I believe when after restarting, it will reappear. Okay, but you can check it from your end. If you use the data analysis, you see that the output, it will also generate details, just like we are seeing details here.
Okay.
Yeah, to generate.
Yes. That's true.
Yeah, to generate a lot of details for you. Okay, but now let's talk briefly about these other options. These other type of regression. Sorry. Okay, so here we have exponential regression, we have linear regression, logarithmic regression, polynomial power regression, and there's even the moving average. Okay, the moving average can also have its own trend line as well. Okay, we are going to do moving average, as one of the methods of forecasting. All right, so also you use the linear method when the relationship between X and Y is expected to be linear, like this. Okay, but like you can see, when you draw the line, you can see that these points, you can see that the points really don't fall on the line, right? That's what I was trying to say before, that when you forecast, you don't expect it to be exact. All right, these points are actual, these points. You see that they are not really falling on the line, but they are on either side of the line. So sometimes the actual will be a little bit higher than the forecast. Sometimes it will be a little bit lower. Okay. But the average, on the average, it will be kind of close to the actual. All right. So when do you use exponential? Use exponential, when when y tends to grow very rapidly in comparison to x. Don't know if that makes sense. Let's delete this. Okay, so let's put an exponential trend line. Now you see the equation of the exponential trend line is different. But the linear is the most important. Why is that? Because why is it going back to linear? Linear is the most important because most of the time you find yourself using linear, and all these other ones, they are convertible to linear. So that's why linear is the most popular, the most commonly used. It's the simplest and also the most commonly used. So I think that's good news.
So so we don't need to bug our head, eh?
Well, yes, don't need to bug your head too much about. So, but I want you to see the nature of this. This is exponential. This is exponential. But the arrow square we are getting from exponential is even lower than what we got from.
Lower than, yeah. So it's not as reliable as the linear.
Yes. Okay. But where do we use this? When y is increases much, much rapidly than x, that's when this exponential is usually suitable. Okay.
Okay.
Yes, that's when it's usually suitable. Then for logarithmic, there's the logarithmic. Logarithmic regression. If you do logarithmic, you can see how it is. Okay. Let me delete this one. For the logarithmic, this is used when it is the x that is increasing rapidly compared to y. When the value of x tend to be very, very high, to grow very much in comparison to y, that is when the logarithmic is suitable. Here, logarithmic is very poor here, okay? It doesn't suit this data at all. So you can see arrow square is very, very small. It's not very small, but it's small. So logarithmic is out for this particular data. Hope we are seeing what I'm talking about. Okay. So for logarithmic, you can see the equation is giving you. Okay. It utilizes the natural log, which effectively will reduce the number. So y becomes a relatively small number. Okay. I hope this is not abstract to us. Any questions? Any question?
Mm-hmm.
But when you are using scatter plot, the beauty of it is that it gives you the equation right away. It's giving you the equation to use. So all
That makes life easier.
yes, makes life easier. All you need to do is get that equation and use it.
And substitute.
Substitute the value of x in there to get y. Simple. Okay. So, but like I said, most of the time, what you need to use is just the linear. So, and it's the simplest of them all.
But if you look at what you just said, I don't know if I missed it towards the end.
Yeah.
But you were talking of different scenarios. I mean, yeah, that when we have what's that one again? Exponential regression.
Yeah.
That is yes, that's it would be more appropriate to use
Exponential in some cases.
yes, that the linear regression may not be too suitable.
Yes.
You know,
that's
when
right.
we have, I think, how do you put it again?
Yes, yes,
Because like the case we're having 73 and 71%.
yes, that's right. That's right. But really, when you are using Excel, what I'm explaining now, I'm just explaining the fundamental concepts, okay? But actually, when you are using Excel, it makes it so easy that even if you don't convert to linear, you can easily just use it straight away. Okay. Now, what I said earlier that most of the time, what people use is linear because all these other ones can be converted to linear. They can all be converted to linear. Okay. However,
Okay.
the conversion process itself is another process anyway. Okay. But if you are using Excel like this, like we are using now, you don't even need the convert. You can easily just pick the formula from here and use it. Now, for example, this arrow squared now, this arrow squared, yeah, of course, this is not suitable, but if we want to pretend that it's suitable, okay, and we want to use it, just like saying equals, like what we did before for 250, 151521 times natural log ln of what? Ln
Of X, which is
250.
advert,
Yes,
publicity.
which was 250 in the example we did earlier, right?
Yes.
Minus
Minus
659,546. Simple. See how simple it is. Okay. But like I said, you can't use this. I've already explained why. Okay. But if it were the most suitable one that you need to use, it's as simple as what we just did now. It's not, is this complicated? It's not complicated. Here it's giving you 1.2 something, but the linear gave us
1.3 something.
okay, 1.3 something. But because of the arrow square, this linear is more reliable than this one.
Yes.
But you can see how easy it is to use it. It's very easy.
Yeah.
Okay, very easy. Okay, now when I say converting it and all that, you know, in modern time, the computers and applications have made things so easy. Okay, in the past, when you want to do this kind of thing, you have to be converting to linear, and that's another mathematical process. But right now, you really don't need to do that. Just pick it and use it. Simple. Just pick it and use it.
Can you talk briefly, maybe can you rephrase briefly about the percentage of acceptability?
Yes, I said if it's 70, that's 0.7.
Can you run the range for us there? Maybe yes.
0.7 above is good. That's good. You accept it. Accept. Or can say good.
So we are multiplying that by like 1,000.
I don't understand. This?
To bring it to about 70 something percent.
No, by 100.
Is it 100?
Yes. It's by 100.
I thought I saw point 7 something something something.
No, I said 0.7. If it's 0.7 and above,
Okay, if it's 0.7, okay.
0.7, which is 70%,
Yes.
that's 70%. If it's 0.7 and above, you accept. That's okay. It's high, it's good. It's good. You can use that. You can use it.
So when we see the R square as 0.466, we're only just considering into the first decimal place.
Come again.
Because we'll be using what we are looking, I think what we are looking at is the R square. Take for instance, we have R square of 0.466.
Yes, that's 46.
Uh-huh.
This one now is
So
46%.
in order to bring it to 46%, we multiply by
100.
that is what I'm saying.
Yeah.
So if we take
So now if I
yeah.
want to say this in percentage, I will say 70%.
Yeah.
I'll call it 70%. It's the same thing as saying 70%. This is the same thing as 70%. Okay. So if it is less than or equals 30%, point 3, reject. If it's in the range of 0.3 to 7. When I say 7, I mean just less than 7. Within that range. Review. Okay. In other words, if you don't want to reject it, you just check again, check your data again, and all that. Okay. And those that are responsible for making decision will decide whether to reject it or not. So this is like fair. Okay, fair. But what is really excellent is 70% and above. This one now, this one that we did now, you see it's fairly okay. At least see what it's giving us. But apart from just giving you a particular figure, this is when your R squared is high, it's telling you that the correlation between the two is high.
Yeah.
Apart from the fact that there's an equation connecting them, the correlation is strong. There's a strong correlation between the two. Okay, so the last one, which I have not explained, is the power. The polynomial is kind of it's like you have a sine curve or modulating curve that goes up and down. Okay. That one that goes up and down like that. That's polynomial relationship. Okay. That's oscillating type of curve. Goes up, some like a seasonal thing, goes up, comes down, goes up, comes down, something like that. So polynomial is suited for that. Our regression is when both the X and Y are growing rapidly.